Alright, welcome back everybody. Today we're going to look at Project 3.1 on our Key Studio ESP32 Smart Home Kit. And Project 3.1 refers to the PIR motion sensor, and we're going to figure out what all of that means. PIR motion sensor has many application scenarios in daily life, such as automatic induction lamp of stairs, automatic induction faucet of wash basin. I think that you can turn on your stair lamp, you can turn on your wash basin faucet. So it'd be like, yeah, a motion detector. If you go into a bathroom at a restaurant and it's a no-touch, it's because of a PIR motion detector. It's also a digital sensor. It is also a digital sensor, like buttons, which has two states. So, we talked earlier about how this button has an on state and an off state. And I'm actually referring to the button when the button is open or closed. Not necessarily this light. This light is a result of the button. But the button has two states, open and closed. And so does this sensor, you see. See, it's been tripped and it has two states. Okay, we will print the value, and those states are values of 0 and 1, which represent open or closed, and will be sensed when people are moving, such as like that. We will print out the value of the PIR motion sensor through the serial monitor. So, done that, and our control pin is number 14. And I've already copied the test code, but let's see here. Oh, this is our test code right here. So actually, let's just let's bring up our bigger picture. So we call this pyroelectric PIR. We'll have to find out what PIR means. Let's try that real quick. Let's see here. PIR motion sensor. Oops. And for the sake of, let me bring this up here. There it is. Okay. So, not that one. Okay. So what is a PIR motion sensor? We ask ourselves. PIR, passive infrared. Okay. It's passive infrared. That's what it means. And it detects movement by sensing changes in the let me embiggen that a little bit. By sensing changes in the infrared body heat radiation emitted by objects. That's interesting, because I thought that was just a photo, like you block the light. So it does this passively, meaning it doesn't emit any energy itself, but instead monitors the existing infrared energy in the area. When a warm object like a person enters the sensor's range, it creates a disruption in the normal infrared pattern, which the sensor registers as motion and triggers a response, such as activating a light or an alarm. So, what does that mean? Should we? How do I? It doesn't appear that we're blocking anything, right? I'm just putting my finger next to it. I can't tell, honestly, if so let's see. PIR, what's the difference between a motion sensor and a PIR motion sensor? So a PIR is a type of sensor that works by detecting changes in heat. Okay, the key difference is that PIR sensors are passive and only sense heat signatures, which helps reduce false alarms like non-heat sources like moving leaves, whereas other motion sensors are active, emitting signals to detect movement. So That'd be like an active would be like shooting out a beam or something that gets interrupted. How it works. So that's detecting infrared radiation. Look at that. How, I'm I'm putting my finger behind it, right? So what could you do with this? I'm putting my finger behind it, meaning I'm not trying to block the path, right? Watch when it comes back on. See, I put my hand here. I'm still trying to figure this thing out, right? Put my hand over here. And I'm not sure what we're detecting, if we're detecting heat or what. But it's pretty... Well, what I say when I put my hand over here is, you can't see it, but like I'm putting my hand like way back over here in front of it and trying to see if I'm setting it off based on, and I don't know. We'll have to dig more into this later, because it seems like even when I put my hand way behind the camera, and I'm talking about 2 feet away from the box, it's still reading something. So I don't know. What are we doing? We're checking it out. We're checking it out. We're fiddling around. But at the very least, we understand the theory of operation, meaning we know what's supposed to happen. Let's okay. Anyway, try and get that squared up in there. So let's look at our code. Let's look at our code. Our code shows us, first we're going to define the pyroelectric, that's what it's called, at pin 14. And then we're going to, our first function here, void, is our return type, because we're not returning anything. We're not returning an integer or a character or a floating number or anything like that. We're just not returning anything. It's just sending the signal straight to the device. So void setup, we see our serial communications are going to initialize, are going to begin, and like I said, I believe this is a baud rate. We're going to go with that notion until I correct myself, until we know for sure. But I believe we're going to begin serial communications with this baud rate. Pin mode, the mode of our pin is going to be as an input. So this pyroelectric up here, that's the mechanical device. That's the mechanical device defined as an input. So we have our setup, and that's going to run every time, every time we initialize this script, this sketch. And then down here we have our loop function. So continuously, and I don't know the timing on the Arduino programming, but continuously, as a matter of like milliseconds, this whole, after this runs, this whole thing keeps running, right? Over and over and over again. So once again, return type is void. We're declaring a Boolean. So what, and it's named pyroelectric value. So this is going to store a 1 or a 0. We are going to run this digital read function on the pyroelectric device. Once again, this is hardware. This is a digital read function. And the result of that gets stored into pyroelectric value as a Boolean, whether it's 1 or 0. And then after that reading happens, we're going to print to the console, the serial console, pyroelectric value equals, and that's going to give us some text, right? And then we're going to serial print line. It's basically going to print to the console once again the pyroelectric value that was stored right here in this variable. After that, we are going to delay for 200 milliseconds, and then it's going to run the script again. So 200 milliseconds is very, very, very quick. You know, it's not 2 seconds. It's, you know, about a fifth of a second. So let's run our script. Let's see what happens. Let's compile our sketch. And we see we got stuff going on here. So this is loading all of this in here. And let's go back to how do we test our result. We test our result. If you stand in front of the sensor, the value is reading 0. Move a little bit and it changes to 1. Okay, and we see that on the console over here, right? So right now it's reading 0, and you can see that the light, I guess it is hard to see, but it'll come back on. Let me bring this down here so you can see a little bit better, because that's there. That light's going to come back on now. There's our light. And what you'll see here in the console, you see it change from, right here you see the change from 1 to 0. When I put my hand in front of the light, see the light goes out and you see the state change in the console. So that's how we know it's working. Okay, fun times. Alright, so I'm going to make that go away. And so yeah, that's our test result. So that's how we know that's working. Now we're already about 12 minutes into this recording, so I am going to go ahead and the next video we're going to do Project 3.2 PIR motion sensor. We're going to test it again, but this is going to turn on a yellow LED, so we're going to do that in the next video.